And welcome back to 3.1 podcast. In our last podcast, we were taking a look at how we make measurements, and we were talking about the fact that you read every increment that's on the instrument, and then you have to guess one additional digit or estimate that last digit. And we left off as we were talking about reading volume off of graduated cylinders or burettes, and so we're at letter C now on the far right hand side. Oftentimes liquids are difficult to read because they have a color associated with them, and it's hard to see where the bottom of the meniscus is. Some, as they get very dark, you have to look very close to see where they're at. And so in this letter C, let's see how we do here. Again, we're going to be reading this instrument down because notice you have 21, it appears to be right here, and 22 is down here, this particular line that goes around the graduated cylinder. As you read these lines down, it appears we have 20. If you have 21 here and 22 down here, it looks like each line is a tenth of a milliliter, where this middle long line is going to be 21.5. So you have 21.1, 0.2, 0.3, 0.4, 0.5 for the long one, 0.6, 0.7, 0.8, 0.9, and then finally once again 22. And so the bottom of this meniscus appears to be, well, again, if this is 21, 21.1, and here's 21.2, it looks like it's between 21.1 and 21.2, so it has to be 21.1 something. And if you look, the bottom of this meniscus, to me, it appears to be slightly less than halfway between these two as you're reading downward. Now somebody might say, well, they think it's right on the halfway point, in which case you would call it 21.15. I think it's slightly less than that, so I'm going to call this 21.14 milliliters. Again, that's where that last digit is estimated, and that's where some error comes into play. Alright, so when you read your instruments, your rulers, your graduated cylinders, make sure that you read all the lines and then estimate the distance in between the lines. Alright? Okay, moving on now. Because there is an inherent error when taking measurements because you have to estimate that last digit, you can only report certain numbers. For example, if I scroll back up, I just scrolled down. Since this burette at letter C, the last one that we did here, since you can only estimate this to the hundredths place, I cannot report this as 21.14000000 milliliters. This says that I'm sure of all of these zeros and I estimate it to that last zero. That would be incredibly accurate, but that's not the case. I'm actually estimating the 4, not this very last zero. So how do you know which numbers are significant and which ones are not? Well, scrolling down, and by the way, this part of the section is going to be optional. There are a few optional components to this chapter. Well, this one will be, but if you are an advanced student and you're going to be taking AP Chemistry or AP Physics or anything like that, you need to know this. So if you're not, feel free to skip over this portion. You can actually stop the podcast right now and move on to the next section. Okay, so for those who are still with us, the way you count the number of significant figures is by using what's called the Atlantic-Pacific rule. You're not going to find this in many textbooks. I learned this as a student teaching, and I love it. So here's how it works. The Atlantic-Pacific rule says, if the decimal, and by the way, here's the United States. Let me explain this just for a second. Here's the picture of the United States right here, and then obviously over here to the right of the U.S. is the Atlantic Ocean, if you know your geography, and to the left of the United States is the Pacific Ocean. And what the Atlantic rule is when the decimal is absent. So you have decimal is absent, you start on Atlantic side, which is the right-hand side. So you have absent A, Atlantic A. When the decimal is present P, you start on the Pacific side. Start on Pacific side. And from there, it's exactly the same. you skip all zeros until a non-zero is reached, and then count all numbers from there. Including zeros. And the same is true for the Pacific rule. Once you're starting on the Pacific side, you skip all zeros until a non-zero is reached. Then count all numbers from there, including zeros. Now in your textbook, it's going to give you rules for trailing zeros, leading zeros, zeros in the middle. I don't like that. I like the Atlantic-Pacific rule. And it's very easy if you see a few examples. So here we go, scrolling down. It says count the number of significant figures in each of the following. In this number, 1,230 meters, the decimal is absent. There's no decimal here, so you start on the Atlantic side and skip over the 0, and now count all the other digits. So you got 1, 2, 3 sig figs. Okay? In letter B here, you have a decimal present. So you start on the Pacific side, which is the left-hand side, and then skip over all zeros. Skip, skip, and as soon as you hit a non-zero number, the 5, you count the rest. 1, 2, 3, 4, including the 0. So this has 4 sig figs. In letter C, here's something slightly different. We have scientific notation, but it really isn't different because the decimal is present. You start on the Pacific side, skip any zeros. There's no zeros to skip, and now count all the digits. 1, 2, 3, 4. This also has 4 sig figs. And letter D, the decimal is absent, so you start on the Atlantic side, skip over all the zeros, and now start counting. 1, 2, 3, 4, 5. Five sig figs. Okay? So that's how you count sig figs. You simply got to use the Atlantic-Pacific rule. Much easier, much easier than using the rule that's in the book. Okay? And in just a minute, we'll continue our podcast going over some more examples dealing with rounding and taking measurements.